first example is about roulette. So an actual game in an actual casino, which you will have a few years before you can go play. Okay. On an American roulette wheel, there are 38 slots. They are numbered 1 through 36, and then there's also a 0 and a double 0. Half of the slots from 1 to 36 are red, the other half are black. The 0 and double 0 are green. Suppose that a player places a simple $1 bet on red. A simple $1 bet on red. If the ball lands in the red slot, any of the red slots, the player gets back the original $1 bill plus an additional $1 for winning the bet. If the ball lands in a different colored slot, the player loses the $1 bet to the casino. So we want to do a few things. First of all, we want to talk about sample space. In terms of our bet, which is $1 on red, what would be our sample space, the outcomes that would be affected by our bet? What's a positive outcome for us? Red, so that would be one of the outcomes in our sample space. What other things would we put in our sample space besides red? Black.
Also green.
And green. So we're looking on the roulette wheel in colors for this particular bet. Okay. If you're looking at numbers, then you have a different sample space. Okay, but we're looking at the colors. Okay, so we want to talk about what is the probability of winning. Which part of that sample space, red, black, or green, is a win for you? Haley says red. Okay, we put the bet on red, so red is going to be a win. So what we need to do is figure out how many favorable outcomes are there? How many red spaces are on the roulette wheel? 18. Half of the 36 are red, half of the 36 are black. How many total outcomes are possible on the red or on the roulette wheel? 38. I usually reduce, so this could be 9 over 19, okay, for winning. So my probability of winning is 9 over 19. Okay. Let's talk about probability of losing. What outcomes are losers in this scenario? Black and green. Okay, so we'll have a lose scenario and a lose scenario. You're going to have to count up all of those unfavorable outcomes. How many black and greens do you have on the wheel? 20, because you have the 18 black and the 2 green, or you could think about 38 minus 18 is 20. Okay, so you have 20 of the other color. 20 over 38 is 10 over 19. In this case, we have only 2 options. We can win or we can lose. We have no option to break even. So when you look at your 2 probabilities, the probability of winning and losing, they're complements of each other. 1 minus 9 over 19 is 10 over 19. Okay, so they're going to be complements. If you have a break even option, they're not going to be complements of each other. Okay, they won't add up to 1. So you'll have to be watching out for that. I'm going to make a quick note right here. There is no break even in this scenario. Okay, we want to create a probability distribution. So that's our values and our probabilities. I'll just label it X for value, P for probability. And talk to me about when I place that $1 bet. What are things that can happen to me in terms of money for value? What can I lose and what can I win? And the different outcomes. Ethan?
You can win $2.
Okay, if I win $2 and I have paid $1, what's my actual profit on my win? $1. So by getting the $1 back that you paid, that's more of like break even. So the actual win is the extra $1. So we could have a positive $1 for a win. We can also have a negative $1 for a loss. Okay, so those are my options in terms of my probability distribution. I can either lose $1 or I can gain $1. Can I ever get to 0 in this game? No, I have no break-even point, so that's not part of my distribution. Assign the correct probabilities. Losing the dollar is 10 over 19. Winning the dollar is 9 over 19. There will be some questions at the end of your quiz, just a few questions tomorrow on mathematical expectations. One thing I could ask you to do is create the probability distribution. So it would look something like this. Get your values in the top row, you put your probabilities in the bottom row. Note that your bottom row should always add to 1. If the probabilities in the bottom row don't add to 1, then you don't have all the probabilities in the probability distribution. Did you have a question? Now we're going to calculate mathematical expectation. Once you have the probability distribution, mathematical expectation is really easy. Okay, if you look back on the top part of your notes, it says take the value times its probability. So -1 times 10 over 19. And add to that all other values times their probabilities. So a +1 times 9 over 19. Now would be an okay time to put this into your calculator, and if your calculator gives you a decimal answer, that's okay, because we're talking about this in terms of wagering $1. So we probably want our mathematical expectation value to be in terms of dollars and cents. Okay, so go ahead and type this into your calculator. See what you get when you do -1 10/19 plus 1 times 9/19. What is our mathematical expectation? Yes, in terms of dollars and cents. Oh, 5 cents. Okay, so 0.05 in terms of dollars. Okay. So we understand this. Like if I only play roulette one time, am I going to lose 5 cents on a dollar bet? No. I'm going to lose $1 or I'm going to gain $1, right? Like those are my two options. What expected value is saying, like, if you continue to play roulette, and this kind of goes back to a conversation you would have had last year with theoretical and experimental probability. The more you play, the closer you're going to get to this value. So, like, sometimes you win, and that feels great, and you keep playing, but then you keep losing. And more often than not, if you play enough, it should come out to your expected value. Okay, so the question is, if you played this game 100 times, there would be sometimes you won, sometimes you lost, because sometimes it's going to land on red and sometimes it's not. What would you expect to win or lose? Take 100 times your expected value. We would expect to lose $5. If you are losing $5, what does that mean for the casino? They are gaining $5. So if you took some time to look at different games played at casinos and their probabilities and expected values, you would assume most of them would be negative, if not all of them. Because what is the casino trying to do? Make money. So that's something for you guys that you can be thinking about as we go into Friday and Monday and you're crafting your games. There's two big issues that I would be aware of when you're doing your actual probability distributions and analysis. First of all, you're going to be wagering 1 Tootsie Roll. Okay? So you don't want your expected value to be too high of a positive number, and that would be like something close to 1. Because the closer you get to 1 for expected value if you're wagering a single Tootsie Roll, that would mean like you're giving out a lot of Tootsie Rolls and your game is really easy. Okay, are games that are super easy and you always win really fun to play? Not really. Okay, not very exciting. You also want to be aware of getting expected values that are really low negative numbers, you know, like closer to -1, because that means you're going to be giving out or taking a lot of Tootsie Rolls and not giving many out. Do you like playing games that you can never win? Not usually. Maybe you might engage for a little bit, but then at some point you're like, well, I'm never going to win this, right? So those are two issues for game day that you'll maybe want to be thinking about when you're creating your games. Is like you don't want to make your game so easy that it's not exciting. You also don't want to make your game so hard that everybody walks away losing. And you go up to the game and you know you're going to lose. Because we're going to play the games that Tuesday in class, and we're hoping that we're like earning some Tootsie Rolls and losing some Tootsie Rolls. Okay, so we kind of got that excitement about, am I going to win or lose? Okay. I had some groups last year who maybe didn't think hard enough on probability distributions prior to the game, and then, like they gave out 2 Tootsie Rolls the whole class period. Okay, well, that wasn't a very exciting game to play or work. Okay, so you'll have more fun if people are kind of like gambling and not knowing what's going to happen. Okay, example 2, I'm going to give you a few minutes to read and kind of get some ideas. If you want to talk in your small groups, that would be okay. Probably in about 4 minutes at about 12 o'clock, I'll come together and kind of put some thoughts down on the board. Space. Sample space.
$1.
Sure, those are the things that you can pull from the envelopes. What's the probability of winning? 1/5, which you got from 2/10, right? So what are the things that you're considered winning?
10, 20.
The 10 and the 20 are wins because you make money off of what you put into it. What would be your probability of losing? 3/5, you got that from what? 6/10. Those are the $1. So they would be our losses. Now, in this particular example, we have a break-even point. Okay, so that $5 bills that's not considered a win or a loss, be aware that it will show up in your probability distribution as a break-even point. What's the probability that you break even? 1/5, 2 out of 10, or 1/5. So notice that now my break-even plus my win plus my loss adds up to 1. Okay, so that's important. When you made your probability distribution, what values did you include? Just give them to me. -$4 would be a good one. If you pay $5 and you only get $1 back, you're losing $4. What other values did you put in? 0. There is a break even. 5 and 15. Okay, so what's interesting about this particular problem is, even though we said that winning was 1/5, we're actually in our probability distribution going to have to break that up so that we have winning $5 and winning $15. Okay, so each of these have a probability of 1/10. The break-even point is 1/5, and then the loss is 3/5. But if I add those up, again, those things are going to add up to 1. Calculate your expected value, and remember, expected value, once you have your probability distribution, you're just taking a value times a probability, adding it up down the line. -4 times 3/5, plus 0 times 1/5, plus 5 times 1/10, plus 15 times 1/10. What did you guys get for expected value? -0.4, so 40 cents. Okay. And if you play this 100 times, how much would you expect to lose? $40. I could see how that could happen pretty fast in this game, right? But how many of you, so I have a negative there, how many of you might see this game and think, I could pull a 20? No? Nobody? It's tempting. $5 into 20 for nothing? More than pulling an envelope? You don't want to play that game?
For a while and see what people think, and then you.
Oh, that seems sneaky. You get kicked out of a casino for counting cards, you know. Beware. Okay. On the back side is the expected value worksheet. So you're working through the 5 games at the top. down below it says for each game described above, answer the questions 1 through 6. They're the same questions we just went over. Okay. I only want to show low, lower, lowest in terms of sample space because some of them have more challenging sample spaces than the examples that we've done. So if I were doing this game, it says the house rolls a die. So they could get outcomes 1 through 6. And then I have to roll a die and I'm trying to get a number less than them. So rather than writing out my whole sample space, you'll see on my answer key, I do something like this. These are the outcomes for the house. They could roll a 1, 2, 3, 4, 5, or 6. And if they roll a 1, I can roll one of those numbers. And I can do that for all of these numbers. So you could certainly list out the sample space 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Or you can draw something more diagram like this. I like this because it will be helpful to me when I'm answering the question for like probabilities of wins and losses. It says in low, lower, lowest, if this, the player must roll a number that is lower than the number that appears on the die of the house. So if the house rolls a 1, can I win by rolling something lower than them? No, there are no wins. If they roll a 2, can I win? Yes, by rolling a 1. If they roll a 3, can I win? Yes, by getting a 1 or a 2. So I like to do it like this because then I can more easily spot my wins and losses. Okay, so know that you have some freedom there with that sample space question to make it easier for you to identify things. I will post this answer key online tonight so that you can check it before you come in to your quiz tomorrow. There will be 2 questions at the end of the quiz about mathematical expectation.